Hello everyone, today let's solve the Leetcode problem number 57, insert interval. So what the question says, you are given an array of non-overlapping intervals, nothing but here you can see in the example 1, intervals they have given. We have given an array of overlapping intervals, where intervals of I is start of I, end of I. This fine, represent the start and end of the ith interval, and intervals is sorted in ascending order by start of I. You are also given an interval, new interval equals start, end. That represents the start and end of the another interval. This is fair. Next, insert new interval into intervals. We have to insert the new interval into intervals such that intervals is still sorted in ascending order by start. So we have to insert the new interval into intervals such that intervals is still sorted in ascending order, right, by start of I and intervals. Still does not have any overlapping intervals. Merge overlapping intervals if necessary, they have given. This is fine. Return intervals after the insertion. So what we have to return? We have to return the intervals after the insertion. Fine. So example 1 and 2 they have given. Here intervals 1, 3 and 6, 9. New interval they have given 2, 5. 1, 5, 6, 9. So the output that we have got is 1, 5, 6, 9. This is an ascending order. This works fair, right? So next, intervals 1, 2, 3, 5, 6, 7, 8, 10 and 12, 16 they have given. New interval 4, 0. Now this is 1, 2, 3, 10 and 12 and 16. So this is also an ascending order, right? Because the new interval 4, 8 and overlaps with 3, 5, 6, 7, 8 and 10. That's why 4, 8, this one 3, 5, 6, 7, 8 and 10 is 8, 10 is not present. 1, 2, 3, 10, 12, 16. This is an ascending order. So let's see. Let's try to write the code and understand with by taking example 1. So initially just come here. First, what we will do, we'll destructure the new interval into new start and new end, right? This is simple. In JavaScript, we can destructure in this, right? So new start, new end. So this will be new interval equals also L and R also we are considering, right? We are initializing this one to empty array. Next, what we are doing, L, what does L and R stating here? L stores intervals that are completely before new interval, and R stores the intervals that are completely after new interval. Just keep in the mind, L stores the intervals that are completely before interval, and R stores the intervals that are completely after new interval, right? Next, what we will do, let's make use of the for loop. I'll just come here. I'll just take individual interval of intervals. Let's iterate through the intervals. Let's just take all intervals. Next, destructure each interval into start and end. We know how to destructure now. This will be start, end. We are destructuring each interval into start and end. Nothing but individual interval, right? INTR. We are considered. This is fine. Next, if end is less than new start, that means if the current interval is completely before new interval, then we add it to L. So I'll just make use of if condition, if end less than new start, then what we will do? Nothing but we will add it to 1, right? If the current interval is completely before new interval, add it to, we are adding that one to L. Nothing but L dot push. For adding, I'll just make use of the push operation, push of INTR, right? If the current interval is completely after new interval, then we are adding it to R. So if the current interval is completely before new interval, add it to L. Then if the current interval is completely after new interval, we are adding it to R. First I said, what is L and R here doing? We are storing the intervals that are completely before new interval for L. For R, we are storing the intervals that are completely after new interval. So here I'll come. So if the current interval is completely after new interval, we are adding it to R. Nothing but here I'll just take else if start greater than new end. Then again for adding, I'll make use of the push operation. So next step, what I'll do, if the current interval overlaps with the new interval, we will be merging it by adjusting new start and new end to cover both intervals. So there are three the conditions, right? One is if the current interval is completely before new interval. Second one is if the current interval is completely after new interval. The third one is if the current interval overlaps with the new interval. Then what we will do, if the current interval overlaps with the new interval, then we will merge it by adjusting new start and new end to cover both intervals, right? So else I'll just directly write new start math.min of start comma new start. This is fine. And let's consider new end as well. This will be max, right? Math.max and comma new end. Next, let's combine the intervals before the merged interval and the intervals after. Nothing but I'll give return. Let's make use of the spread operator. L, comma, we are merging. What are all the things that we are merging? Combining. We are combining the intervals before the merged interval as well as the intervals after. Nothing but intervals after, intervals before, and the merged interval, right? L, R, and new start and new end. So spread operator for L I have used. And then new start and new end. Let me give here new start, comma, new end. Here, finally, our spread operator for R I have used. So let me format the code, hit the submit. So this works absolutely fine, right? So let's try to take this example and understand, right? Implement the same thing. Just give me a second. So let's go for the step-by-step explanation, right? So let me come here. Let's consider this example. So here new intervals, intervals they have given 1, 3, 6, 9, and the new interval is 2, 5. So the output that we got here is 1, 5 and 6 and 6, 9, right? So initially what we'll do according to the code, so we'll come here, we will destructure new interval into new start and new end. Nothing but new start will be this one. New start will be 2 and new end will be 5. I'll just take here ns is new start. New start is 2, right? And new end, I'll just take ne. New end is 5. So new start will be 2 and new end will be 5. We are creating the empty arrays L and R for the L and R, right? So this one, we are creating L and R. Then what we will do, we will iterate through the intervals. Here, we'll come to this step. We will iterate through the intervals. First interval we have is 1, 3. This one, let's consider 1, 3. I'll just come here, 1, 3. Let's consider 1, 3. Let's go slow so that we understand clearly. So since 3 is greater than or equal to 2, nothing but new start. This one, 3 is greater than 2, right? 3 is greater than or equal to 2. This one will come. 3 is greater than or equal to 2 and 1 is less than or equal to 5, nothing but new end. This one, new start and new end we are checking. So since 3 is greater than or equal to 2 and 1 is less than or equal to 5, this one, new start and the new end we are checking, right? 1 is less than 5, we know. 3 is greater than 2 and 1 is less than 5. So these intervals overlap. So we'll be merging them, right? Now the new start equals min of 1, 2. New start will be this step we are coming. This step, right? New start will be min of 1, 2, nothing but 1, right? New start will be min of 1, 2, nothing but 1, and new end will be this one. New end, mat.max of end, new end, right? Nothing but new end of max of 3, 5. Nothing but new end will be 5. Max of 3, 5 is 5, right? So new end will be now 5. New start will become 1 and new end will be 5 now. I hope this is clear. Let's come to the second interval, 6, 9. This is, right, 1, 3 is completed. Now let's come to the second interval, 6, 9. Since 6 is greater than 5. 6 is greater than 5, right? This one. Directly going. 6 is greater than 5, nothing but the new end. This step. 6 is greater than 5. It does not overlap with new interval. So according to this condition, else if we have written here new end, you can clearly see start greater than new end. And 6 is directly greater than 5, new end. It does not overlap with the new interval. So we are adding 6, 9 to the right array. Directly we are adding the 6, 9 to the right array, right? So in this step we got 1, 5 because here you can clearly see we had to go for the merging, right? Because we saw here 3 was greater than 2 and 1 was less than 5. So intervals overlapped. So we merged. When we merged, we got new start. We came to this step. New start of 1, 2, we got 1. New end of max 3, 5, we got 5. So here 6 is greater than 5. It does not overlap with the new interval. So we are directly adding this one. We are directly adding 6, 9 to the R array, right? So third step, what we are doing, we will combine the results. So the final result is this one. Let's come here, this one, right? The final result is nothing but the spread operator of L, new start, new end, and R, right? So we have to give everything. The answer we got here is 1, 5. We are matching, right? So this will be 1, 5 left that we got after merging. Next 6, 5 we push to R, right? 6, 9. So now we have 1, 5 and 6, 9. So the solution that we got, the answer that we got and the output shown here is same, right? 1, 5 and 6, 9. So the code works absolutely correct. So let me delete this. So in simple terms, what we can say, intervals before new interval 1, 3 is merged with 2, 5. So here, this one, interval 1, 3 is merged with 2, 5 to become 1, 5. We saw how we merged and how we got 1, 5, right? So intervals after new interval 6, 9, this one, after new interval 6, 9 remains unchanged. We can see this condition here. Start greater than the new end. We are just pushing the R, interval to R, right? So 6, 9 remains unchanged. So the new, this one we got is 1, 5 and 6, 9. So I hope this is completely clear. So what would be the time complexity and the space complexity? The time complexity would be big O of n. We know that n is nothing but number of intervals. So why this time complexity is big O of n? Because the function is iterating through the intervals only once here. We can see this one clearly here. The function iterates through the intervals once. So it runs in linear time. So the total time complexity would be big O of n. let me come here, it would be big O of n. So what would be the space complexity? The space complexity would be big O of n as well. Why? Where n, we know that n is nothing but number of intervals. Why? The space complexity is linear. Why the space complexity is linear? Because we are storing the intervals in new arrays, L and R. We saw the new arrays, right? That's how we got the output here, 1, 5 and 6, 9. So we are storing the intervals in the new array. New array. This one you can consider, or here, this one. New interval we have created, L and R. We are storing the intervals in new arrays, L and R, and we are returning a combined array. Right? So the overall space complexity would be big O of n as well. So I'll just come here. Let me give big O of n. So let me commit this one. Yeah. Let me hit the submit again. So yeah, this works absolutely correct. Right? So this is it. Thanks for watching, guys.